around all the classes in one go.
Yes.
So 10 to ask you this time. Okay. Any questions for me? No? Okay.
We look forward to what you're
Next
selling
Wednesday.
next time.
Bye.
All right. Okay, we'll start with the tutorial. If you tried the questions, how did you get on? Hmm?
Can we do a question true for simple harmonic?
Mm-hmm. Yep.
Oh yeah, I have a lesson for 7.
For which lesson? Simple harmonic?
No, the other one. Circular motion.
Let's start with Dorian's question, simple harmonic number 3. So, what is the story in that one, if you can read it to me, please? Oh, I'm getting it handed to me, thank you. So, can you see? This is number 3 for simple harmonic. You got a pendulum? Oh, maybe you can't do this one yet. Maybe it's, because I'm going to do the pendulum today. Amplitude of 30. Yeah, I'm sorry. That should be in the next lesson. We're doing pendulum today. Yeah, so you can see the next lesson is called the pendulum. So I should move that down. Apart from number 3 then, was there any other problems then? You said circle.
Yeah.
Which one in circle?
Number 7, B2.
7.
Because they use another formula which I don't know. Like
Well, let's see. So, what is the angular velocity? That's omega equals 2 pi over t. Sorry, this is number 7b in circular. So what this Lynn, is happening is it's just the Earth going around the Sun. So the time will be 365 days times 24 hours times 3,600 seconds in an hour. That's the omega for the Earth going around the Sun in a circle. Does anyone have that number for me?
Yeah, 315, 36, 3 zeros.
Like this?
3 zeros.
Radians per second?
No, second.
315. Huh?
315, 36, 0, 0, 0.
This seems too big. It should be really small.
The line is
Seconds in a year.
Yeah, but it's a small number over a big number.
mine. I got 1.
I got that and then I switched it.
1 point.
99
Yeah,
times 10 to the power negative 7.
that seems more like it. Diego? I'm not sure what you typed in.
the actual result, that's no, I thought it was saying.
Okay. And then the last part is what's the acceleration?
Yep.
You could use the formula v squared over r, right? And then you can say v is omega r.
Yeah, that's the one I used.
Okay, fine.
It gave me.
So that's omega squared r squared over r, which equals omega squared r, which equals 1.99 times 10 to the minus 7 squared, and then the radius is 1.5 times 10 to the 11 meters.
11.
Yeah, because it's 10 to the 8 kilometers. What did you do wrong?
I don't know.
Nice now.
Hold on.
Did you write that down? Yeah. So I'll update the database, but we're moving question number ID 392 to the next lesson. which is today's lesson. Yeah.
ID 392.
That's question 2 on simple harmonic motion.
Shouldn't that be question 3?
3? Huh? What the heck? Oh, sorry, I'm looking at, sorry. Simple harmonic motion, question
3.
3, ID 15.
Yeah.
ID 15. Thank you, Zach. Right, anything else we need to look at?
Once you go.
Oh, I don't know. Someone has to type it in for me.
Okay.
What is it?
5.9.
I don't know if it's right because it's a very small number.
It should be. It should be.
5.95 times 10 to the minus 3.
Yeah, it should be that.
Yeah, you got that?
No, the thing is, it should be that, but I don't know what. Ah!
What you do wrong?
Okay.
Towards the south.
The acceleration, I know, is small because you can't feel yourself moving in a circle around the sun. Right? Like as you sit here, you don't have a sensation of going, "What? We're turning around the sun," like you might on a bus or a car, you know?
Isn't that because we are used to it?
No.
It's relative.
No. If the acceleration was greater, you would feel it, you know? The same goes for the Earth's rotation. You know, we're rotating around the Earth. We don't feel that. Everything feels static because the accelerations are small.
Relative to the acceleration due to gravity.
Yeah, of 9.8, you know. But there are experiments where you can like detect this. There's an experiment with a giant pendulum.
Oh, yeah, the ones that
Yeah.
I've seen that one.
That one is to pick up the circular acceleration due to the rotation of the Earth. So, I mean, it's small, but it's still detectable by experiments. Old experiments. Okay.
And then you put domino things.
They stick a pencil at the end of it and they see the path that it traces out. So it kind of does a sort of a petal flower pattern. Okay. Do you have this?
Yeah.
It's okay? Yeah? Will we go to the next lesson or are there other questions you want me to do? Now, I should tell you my plan. My plan is after we finish pendulum, I want to give you time in class to finish all the questions in the workbook. So any questions you skipped or missed, you need to have them all finished before the midterm break because your exam will be a collection of these questions. And I'm going to give you a lot of them in the exam. So much so you'll be really sweating to finish it, okay? But they'll all be questions you've seen before. I'm not going to give you any new questions. I'm just going to take the questions in the workbook. I'm going to take random questions. If you can do all the questions in the workbook, then you'll be fine in the exam. But like I said, there'd be a huge time pressure. You really want to be able to do these quickly. Yeah. So do you have another question? Or yeah. Well, look, after we finish pendulum, I'll give you time to work on your workbook questions. And if questions come up that you can't do, we'll do them together. Okay? So let's have a look at pendulum now.